Okay, in this video we're going to finish up 3.3, dividing polynomials, and today the big idea is using this synthetic division. We can use synthetic division to divide polynomials if the divisor is in the form of x minus some number. Now don't worry, if you get like x plus 3 and we're going to divide that into a longer polynomial, think about that plus as a minus a negative. So in this case, our c value would be a negative 3. Not just the 3, because it's always x minus that number. Okay, here is our first problem. We're going to divide 5x cubed plus 6x plus 8 by x plus 2. Now, if you're following along in your notes, you don't have to do this part because we've seen this in the previous video. We got our 5x cubed. We are missing our x squared, so I'll plug in a 0x squared to hold its place, plus 6x plus 8. And we would divide like this. Again, to save time in this video, I'm going to use a little mathematics. So that is going to be and poof, there's our answer. 5x squared minus 10x plus 26 minus 44 over x plus 2. Remember, the 44 is the remainder, and we always put that over our divisor to make it into a fraction. So there is how we did it yesterday, or in the previous video. There's how we can divide x plus 2 into that. And I'm going to come over here now. Make sure you put this in your notes. We're going to do a side-by-side of synthetic division. So I'm going to just scribble that same problem up here. Here's our x plus 2, and we were going to divide that into our bigger polynomial, 5x cubed, plus our placeholder, 0x squared, plus 6x plus 8. Let's see if synthetic division is easier. So here's our setup, just like we saw on the left. I am going to find my c value, x minus c. So here I see a plus 2. I just sort of like to think, okay, I'm going to switch the sign. Now it's a minus 2. Notice I sort of put it behind this little block. Now from the longer polynomial, I only need the coefficients. So I'm going to bring down the 5. I'm going to bring down the 0. I'm going to bring down the 6. And I'm going to bring down the 8. If there were any of those were minus signs, I'd also bring down the minus sign with it. This problem, there were no minus signs at all. I'm going to leave a little gap in here for a row of numbers, and I'm going to put a long line across there. Okay, the first term drops down. That's our 5 below the line. The rest of this synthetic division algorithm is multiplying and adding. So I'm going to multiply negative 2 times positive 5 and bounce right up here. That's negative 10. And now I add these numbers, negative 10. Multiply negative 2 times negative 10 is positive 20. And I add these numbers, 26. Multiply negative 2 times 26 is negative 52. 8 minus 52, if we add those together, we get negative 44. I started with an x to the third here, and I divided by an x to the first, so that gives me x squared. That tells me this first number 5 is 5x squared, and then my powers, or my exponents, will go down. Minus 10x to the first, plus 26 with no variable at all, and then minus 44 over the quantity x plus 2. Look at that answer, and look at this answer. Exactly the same. Synthetic division for most people is much easier. And that's the idea. Again, whatever this is, switch the sign, bring it down, drop down all your coefficients, leave a gap in there, draw your line, and then bring down your first 5, and you multiply and add. Again, it looks like this. We go down, multiply by the 5, bounce up here. Negative 2 times this negative 10, bounce up here. Negative 2 times the 26, that answer bounces up here. And then all the columns we are just adding. And that is synthetic division. Okay, the remainder theorem. Let's consider the division algorithm when the dividend f of x is divided by this binomial x minus c. In this case, the remainder must be a constant because its degree is less than 1, the degree of x minus c. So our dividend f of x, we break it into the divisor, x minus c, times that quotient plus a remainder. The remainder r is a constant when dividing by x minus c. Now let's evaluate the function f at that point c. Okay, if I plug f of c, you know c goes in for all the x's, so this term becomes c minus c times whatever this is, q of c plus r. Well, c minus c, that turns into a 0. 0 times this q of c, that just wipes it all out, so we're left with r. f of c is equal to r. What does this last equation mean? If a polynomial is divided by this quantity, x minus c, the remainder is the value of the polynomial at that point c. And this result is called the remainder theorem. The remainder theorem states if the polynomial f of x is divided by this binomial x minus c, the remainder will be f of c. We evaluate the function at that point and we get the remainder. If that's a little confusing, seeing it side by side happen here in the next example should clear it all up. Example 5. Use the remainder theorem to evaluate a polynomial function. Given f of x is equal to all of this, use the remainder theorem to find f of 2. Okay, let's do that. So we are going to find, or divide this then, our polynomial by 2. We'll use synthetic division, of course, because it's easier. This is f of positive 2, so we're going to divide this by positive 2. Let's bring our coefficients down here. In front of the x cubed is a 1. In front of the x squared is a minus 4. In front of the x is a positive 5. And our constant is 3. So let's synthetically divide. Bring down our first term 1. 2 times 1 is 2, and we add those numbers. 2 times negative 2 is negative 4. Add those numbers. 2 times 1 is 2. Add those numbers. Our remainder is 5. So r equals 5. We could also find f of 2 by evaluating this function at 2. F of 2 is going to be 2 to the third power minus 4 times 2 squared plus 5 times 2 plus 3. So we're just evaluating the function at that number 2. Well, let's see, 2 to the third is 8 minus 2 squared is 4 times this 4 is 16 plus 5 times 2 is 10 plus 3. When I look at something like this, I like to add up all my positives. I got 8 plus 10 is 18 plus 3 is 21. 21, and then I have my negative number 16. 21 minus 16 is 5. Look at that. So if we're going to divide our polynomial by this number, the remainder is actually the value of the function for that x value. We divided by 2, our remainder was 5. F of 2, the output was 5. So there is the use of the remainder theorem. We also have this other one, the factor theorem. Let's look again at the division algorithm where the divisor is in this form, x minus some number c. Well, here's our dividend. F of x is equal to x minus c, our divisor, times some quotient plus or minus our constant, our remainder. By the remainder theorem, the remainder r is f of c. So we can substitute in f of c in place of that r. So this r is out and now is in there in its place f of c. Notice that if f of c is equal to 0, then this f of c is gone. So we're just left with f of x equals this quantity x minus c times q of x. So that x minus c is a factor of the function f of x. This means that for the polynomial function f of x, if f of c is equal to 0, then that x minus c is one of the factors of the polynomial. Let's reverse directions and see what happens if x minus c is a factor of f of x. This means that f of x is x minus c times q of x. If we replace the x in f of x equal to x minus c times q of x with c, we're going to replace this. So again, we're going to evaluate this at f of c. So I'm going to replace this x with a c. So now that term becomes c minus c times q of x. Again, x is replaced with c, so now that's q of c. So that's going to equal c minus c becomes a 0. 0 times q of c is 0. Thus, if this x minus c is a factor of the polynomial, then f of c is equal to 0. We have proved a result known as the Factor Theorem. If that was a little confusing, again, I hope an example or two will help straighten it out. Here they've condensed it down to this box. Let f of x be some polynomial. If f of c is equal to 0, then we know x minus c is going to be one of our factors of the polynomial. And on the flip side, if we know that x minus c is a factor of our polynomial, then we know that f of c is going to equal 0. Okay, where might this be useful? Let me move this up a little bit here. So, solve this equation. 2x cubed minus 3x squared minus 11x plus c is equal to 0. Okay, if we wanted to solve that, we would want to break this down into some factors. Since it is a third power polynomial, it's probably got 3 factors. Okay, we know this 2x cubed has to come from a 2x times an x times an x. The rest of this would be very difficult to fill in. It'd be a lot of trial and error and a lot of pulling our hair out trying to figure out what those other numbers are. But they did give us a clue, given that 3 is a 0 of this polynomial. Aha, so they gave us a clue. We know that 3 is a 0. I know that f of 3 would equal 0. If I plug a 3 in for all the x's, I will get a 0 to pop out. That is also going to help us factor this. Okay, here's our polynomial. Let's get ready to synthetically divide. We're going to divide by positive 3. Bring down our coefficients. A 2, a negative 3, a negative 11, and a positive 6. So bring down your first number 2, multiply, and we get 6. Add those numbers, we get 3. 3 times 3 is 9. Add there, we get negative 2. 3 times negative 2 is negative 6. Our remainder is 0. So remember now, this was a factor that we knew of. So let's put it back in the form of a binomial. That is going to be x minus 3. What do we have here now is 2x squared plus 3x minus 2. Okay. Now this, I'll underline in red. Since we got it down now to a squared power, we should be able to factor this using methods we've previously used in the course. Okay, we know this x minus 3 is a factor. Let's break this up. Couple empty binomials. How do we get 2x squared? Well, that's got to be from a 2x and an x. What are the factors of 2? 2 and 1. Now the trick here is, where does the 2 and where does the 1 go? Whatever goes over here gets multiplied by this 2x, and we want to wind up with our outers and inners adding up to a 3x. So I can put a 2 or a 1 here. Well, let's see, I want to get close to 3. Well, 2 times 2 will get me to 4, and then a 1 here will get me to the 3. Well, let's see, I want to end up at a positive 3, so these I'm going to want a positive 4x and then a minus 1x to get me to the positive 3 in the middle. It looks like we got it. I need a little more room here. Again, back to the original problem, it does say solve the equation. When it says solve, we want x equals. So if we have 3 things multiplied and the product is 0, we can set each factor separately equal to 0. If the first factor is equal to 0, x is 3. If this second factor is set equal to 0, we would add 1 to both sides and then divide by 2, positive a half. If I set this one equal to 0, I get x equals negative 2. So what is our solution set? Well, the lowest number is negative 2, and then a positive a half, and then a 3. There's our answer. Again, if we tried to factor this, old school, just breaking it up and trial and error, it might be a long, hard process. But they gave us a hint. They gave us one of the zeros. So we factored that one out and found what was left. And then what was left was a quadratic, which we factored through a more simple trial and error. And that is the end of example 6. So what do we got left? Based on the factor theorem, these following statements are useful to solve polynomial equations. If your polynomial is divided by this factor x minus c and the remainder is 0, then c is a 0 of the function, and c, whatever that number is a root of the polynomial equation f of x equals 0. And then we can reverse that. If f of x is divided by x minus c and the remainder is 0, then x minus c is a factor of the polynomial f of x. 3 problems for you to try on your own. So pause the video, try these. These mirror the examples very nicely. Fire the video back up and see if you got them right. Okay, let's see what happens in the first one here. Synthetic division. Of course, I'm going to write this out, old school, just so we can see how it applies to synthetic. There's our x plus 2, and we are going to divide that into x to the third. Notice we're missing the squared term, so we need our placeholder, 0x squared, minus 7x minus 6. Okay, let's get ready to synthetically divide. Remember, we want x minus c. So this would be x minus a negative 2. Or again, I always just thought when I was in high school, I see that as a positive 2. I'm going to switch the sign to a negative 2. Now I bring down my coefficients. 1, 0, negative 7, negative 6. Draw our line below. Drop your first number 1, multiply, and add. Multiply and add. Multiply and add. There we go. So we know that x plus 2 is one of our factors. And what remains is, or I guess what they're asking us for here, this is not relevant to what they're asking. Use synthetic to divide this by that. Well, let's see here. We started with a third power. We divided by a first power. So our first number here will be 1x squared minus 2x to the first, and then our constant. We could factor that farther, but that's not what they were asking us to do. We divided this by this, and here's our answer. Number 5. Use the remainder theorem to find f of negative 4. So we could plug the negative 4 in for all of these x's and compute that. But there's always a good chance to miss a negative when you're cubing or squaring something. There's a lot that could go wrong. So we can use the remainder theorem. If I take negative 4 and I synthetically divide it into 3, 4, negative 5, and 3, I should get the same answer. Again, drop down your leading term, 3, multiply, negative 12, add, multiply, positive 32, add. What do we got here? Negative 4 times 27, negative 108. And then that takes us to negative 105. So f of negative 4 is equal to negative 105. If you're not entirely convinced that you did everything right, you can always check by just finding f of negative 4. That's going to be 3 times negative 4 cubed plus 4 times negative 4 squared minus 5 times negative 4 plus 3. Again, there are plenty of opportunities to make a sign error or just order of operations error. We do the exponents first. Negative 4 cubed would be negative 64. Negative 64 times 3 is negative 192. Here, the negative 4 squared is positive 16 times positive 4 is plus 64. Minus 5 and minus 4 multiply to a positive 20, and then we have plus 3. If I add up, again, this is the way I like to do it. I add up all my positives. That would be 84. Plus 3 would be 87 minus 192. And that takes us to negative 105, just like we found with the remainder theorem. Last one, number 6. solve this equation. 15x cubed plus 14x squared minus 3x minus 2 is equal to 0. So again, we want to factor this down and set each factor separately equal to 0. Especially because that number there is more than a 1, this would be a huge trial and error mess. But they gave us a clue. -1 is a 0 of that polynomial. So we will use a little synthetic division to knock our highest power down from a cubed to a squared. So there's our -1 we're going to divide into, and we have our 15, 14, minus 3, minus 2. No power of x's we're missing. We had a third, a second, a first power. So let's do a little synthetic division, and we'll bring down our 15, and we will multiply, and then add them, and then multiply, and add, and multiply. So there's our remainder 0, and that's how it should work because they told us -1 is a 0 of the polynomial. Again, let's not forget to bring this factor down. That is going to be, again, we'll switch the sign here, x plus 1. And now what do we have? 15x squared minus 1x minus 2. And this is all equal to 0. So we did get this down to a more manageable way to factor this. Okay, let's see. This is a 2. The only factors of 2 are 2 and 1. We want to add up to a -1 in the middle. Here's the tricky part. 15. What are the factors of 15? Well, 1 times 15, but they usually don't go for those when we're doing a textbook example. 2 doesn't work. 3 works with 5. 4 doesn't work, and then we're back to 5 times 3. So if I'm going to just trial and error, I'm going to first go with this one, 3 and 5. So which one goes where? Of course, there is going to be an x and an x. So if I put the 5 here, I'm going to multiply that 5 times the 2 and get 10, and then I'm going to have a 3 here. So we're going to have a 10 and a 3. The difference between them would be a 13 or a 7. That's nowhere near this. So let me try to switch them. Maybe if I put the 5 over here and the 3 over here. Again, this is just an exercise in checking your outers and inners. My outers multiply to 6x. My inners multiply to 5x. The difference between 5 and 6 is 1. So I just got to figure out the signs, positive or negative, to make this a negative in the middle. So I want the bigger to be negative. I want this 6 to be negative, so that means I'm going to have to make this a 5x minus 2 and this a 3x plus 1. And ooh, yeah, that worked just nice. Again, I always like to double check at the end. Outers minus 6x, inners plus 5x. If I add those, I do get to the -1 in the middle. So it looks like we are good there. And let me just back this up. I guess we don't need this anymore. They did ask us to solve this, and we're close now. This is all equal to 0. So we will set each factor equal to 0. If x plus 1 equals 0, subtract 1 from each side, and we get -1. If we set 3x plus 1 equal to 0, the first thing I will do is -1 from each side, and then I will divide by the 3, so x is -1/3. If we set 5x minus 2 equal to 0, first thing I do is add 2 and then divide by 5. So we add 2 and then divide by 5. There is our solution set. The most negative number will be the -1, and then the next number would be -1/3, and then +2/5. So again, this would be very hard to factor without this given clue. As soon as we know one of the zeros, we can pull that factor out and then work the rest of it down to a more manageable quadratic. Good times. Here's the homework, page 374. We've got this series of questions. Pay special attention to the evens.